Welcome to Physics World Online College, where we deal with the subject of physics and demystify the concept of physics for everyone to understand. In our class of today, in Physics 101, we continue with scalar or dot product, that is multiplication of two vectors to give us a scalar quantity. In our last class, we emphasized that two vectors A and B, when they multiply themselves, will give us magnitude of A times magnitude of B cos the angle between them. And then we said if the angle between them, the two vectors A and B, is 90 degrees, it means cos 90 gives us 0, which means the two vectors are mutually perpendicular to each other. And we also applied it to the what? The unit vectors I, J, and K, where we said if the unit vectors are mutually orthogonal or perpendicular to each other, it means I dot J, I dot K, J dot I, J dot K, K dot I, K dot J will be equal to 0 because they are mutually perpendicular unit vectors to each other. On the other hand, we said if the two vectors A, B are parallel to each other, it means they are going in the same direction, where the angle theta is 0, cos 0 is 1. In that case, the two vectors multiply each other gives you a maximum value. Magnitude of A times magnitude of B. How does it apply to unit vectors? It means that if two unit vectors are parallel to each other, then I dot I, J dot J, K dot K is equals to 1. We are going to now apply these two concepts to obtain a general equation for solving dot product or scalar product. Hence this class of today. So let's see it. Let's consider two vectors. Let's consider two vectors A and B, such that vector A is AXI, AYJ, AZK, and vector B equals BXI, BYJ, BZK. Then the dot product or scalar product of A, vector A, and vector B is given as, observe what I want to do now. So A dot B is equal to, I take the AXI, AYJ, AZK dot, that is multiplying the other vector B, giving us BXI, BYJ, BZK. Now, we are going to expand because this vector is multiplying this. Let's expand. It means vector A dot B on expansion, AS will multiply everything here. That gives us ASI multiplying BXI plus BYJ plus BZK. plus AYJ, multiplying everything, BXI, BYJ, BZK, plus AZK, multiplying everything here, AZK multiplying BXI, BYJ, BZK. So we're going to open the bracket. That gives us vector A dot vector B equals AX times, this is scalar multiplication. Okay, this is vector multiplication. We have AX times BX, give us AX BX, then I dot I. Then we have AX BY I dot J for the unit vectors. Then we have AX BZ I dot K for the unit vector. Please, you have to be very meticulous when you are solving this question. Now we expand for the second one. We have plus AY times BX. That gives us AY BX J dot I plus AY BY J dot J plus AY BZ J dot K. Then plus for this one AZ BX K dot I. And then AZ, and put that one here, plus AZ BY K dot J plus AZ BZ K dot K. Good. So we are going to put into play this our consideration. Say, but you recall that I dot I equals J dot J equals K dot K. When the unit vectors are parallel to each other, it will be 1. So anywhere I have I dot I have J dot J, and I have K dot K, I will put 1 there. Also, we said I dot J, I dot K, K dot I, K dot J, and then J dot I and J dot K. They are all equal to what? 0. So anywhere I have these perpendicular unit vectors dotting each other, I will put 0. So if we substitute, the expression will give me A dot B equals, here I have I dot I. So I will put 1. That gives me ASBS, that's times 1. Here I have AXBY I dot J is 0. So that component goes to 0. I have here AXBZ I dot K. I dot K is 0. That component goes to 0. I have AYBX J dot I. J dot I is 0. So that component goes to 0. I have AYBY J dot J. J dot J is 1. So that component will remain. So I'm having AYBY times 1. So it remains plus AYBZ J dot I is 0. That component goes to 0. AZBX K dot I. K dot I is what? Is 0. That component goes to 0. AX AZ BY K dot J is 0, so that component also goes to 0. And I have AZ BZ K dot K. K dot K is what? 1. So that component will remain. So I have AZ BZ multiplied by 1. So all the components that are 0, they disappear, while the ones that are 1 remains. So we have AX BX plus AY BY plus AZ BZ. This gives me a scalar quantity. So if you dot two vectors, you obtain a scalar quantity. So in summary, we must not do this long expansion. We do it only when we are trying to show or prove. In summary, when you are given two vectors to dot them, you just simply dot the two vectors that are alike. So let's do that. So in summary, which is what we will use in the examples that we solve, and also in the assignment, I will want you to use that too. If a vector A dot a vector B, and A is ASI, AYJ, AZK, multiplying BSI, BYJ, and BZK. These two vectors are dotting each other. All you just have to do, vector A dot vector B, is I will use this to multiply this. AX, BX. I don't need to do the other multiplications. I will use this AY to dot this. I will have AY, BY. Then the other ones not needed, I will use this one to dot this to give me AZ, BZ. This is direct answer. And that is what we are going to apply in the examples we are going to solve, and then in the assignment I want you to solve as well. So this is a shorter form of doing dot product or scalar product. So let's solve the example as we have it. So we are given two vectors, vector A and vector B are expressed as shown. So let's put that into application. So solution to example. Solution to example. We are given vector A as 3i minus j plus 3k. And then we are given vector B as minus j plus 2 minus I plus 2j minus k. And we are asked to find the dot product between A and B. Option A, we have that A dot B, which means vector A, 3i minus j plus 3k, dot vector B, minus I plus 2j minus k. Like I said, in this case, I will just multiply 3 by minus 1, being the component of I here and I here. That gives me 3 times minus 1. And then I will do j to j. This is minus 1 multiplying 2. And then I do k to k, giving me 3 multiplying minus 1. So that gives me 3 times minus 1 is minus 3. Minus 1 times 2 is minus 2. Plus 3 times minus 1 is minus 3. So that gives me what? Minus 6 minus 8. You see, that gives me a scalar quantity. So if you dot two vectors, the resultant will be what? A scalar and not a vector. That is what that shows. Then there's something the option B wants us to also prove, which is whether dot product is commutative or not? So B says we should find the dot product of B and A. So we have vector B dot vector A. I told you in vector order is very important. So that gives you B is minus I plus 2j minus k dot A is 3I minus j plus 3k. So we dot it, like I've said. What you just have to do, since it's a dot product, like for like. So I will dot coefficient of I with coefficient of I. That gives me what? Minus 1 times 3 plus coefficient of j dot coefficient of j, that is 2 times minus 1, coefficient of k and coefficient of k minus 1 times 3. That gives me minus 1 times 3 is minus 3. This is minus 2. This is minus 3. Once again, giving us what? Minus a. So what does this show or tells us? Which is what they say, what do you observe? Or what conclusion can you draw? So this shows that dot product obeys commutative law. Dot product is commutative. So A dot B is what? B dot A. C. Dot product obeys commutative law. Commutative law. That is A dot B equals B dot A. Likewise, if we do this, you will still confirm that dot product also what? Obey distributive law. Dot product also obeys distributive law. Distributive law. That is A, vector A dot vector B plus C is equal to, you open a bracket, you have A dot B plus A dot C. So if you do this, you first of all sum this B plus C and then dot the outcome with A. It will be the same thing as dot A and B and dot A and C, and adding them together. You will get the same what? Answer. I leave you with this assignment to do. Please do well to attend to it. Then comment, post your answer on the comment section. I will respond to you there to tell you if you are right or not. In our next class, we'll look at case 3. We'll look at case 3, which is a cross product of vector multiplication of vector product. I see you in that class. Bye.